Hi, welcome back. And in this video, we want to demonstrate how to capture rising or falling edges at an input pin, what's called input capture. This, in many ways, is the reverse of PWM. Okay, so let's talk about this. We've used timers and wrote code to time falling or rising edges, voltage signals, rising or falling edges, uh, that have been connected to buttons or photo gates. That's a really common thing to do in programming PICs. So in fact, there are modules that are dedicated to doing just that. Same thing we did, but much more simply. So what it does, it times the edges on a particular set of pins called ICX. The X is 1 to 5, meaning there's 5 input capture modules. So we could capture up to 5 times for 5 different edges. There are no IC pins separately on this board, and you first need to reconfigure the programmable pins. Okay, so you'd look at which pins you want to use. You just choose the ones that are convenient for you. Now, this is a timing operation, and so you need to use a timer as well. And you can use either timer 2 or timer 3. There's 16-bit timers, or you can combine them together to be a 32-bit timer, which means you can time much, much longer intervals. You always configure the timers before the input capture module. So we'll now spend a little bit of time talking about how the input capture module works. The first thing is that there's a buffer. A buffer is just a piece of temporary memory that holds the timer value, the value that you would get from something like read timer, right? When you find an edge. Except you don't have to read the timer. The input capture module collects that value and puts it in the buffer for you. Now the thing about buffers is they're only temporary. So the next time a timer value comes in, it'll overwrite that previous value. So your job when you're reading code is that you must save the buffer value to permanent memory before it's overwritten. Now, to help you with that coding, there's a one-piece bit of memory called a flag, which tells you when a buffer has just been written. Okay, so you check to see if the flag has been sent, then you know there's a piece of information. You write that to permanent memory. So in your code, you check to see if the flag is set. If it is, you record the time value to permanent memory, clear the flag, and then you wait for the next interval. Let's see if I can give you an example that's clear enough to explain what's going on. So below, I have an input capture module configured to give the time for every rising edge. That's where the voltage on the pin goes from low to high. The signal is shown here in blue, right? So we don't know the time here. But what we're trying to do is we're trying to find the time from rising edge to rising edge. It's going to turn out that we're going to get from this blue dashed line to that blue dashed line because of imprecision in timing. But with a bit of luck, that'll be very close to what we want. So the input capture module excuse me, will ignore any falling edges. Falling edges are labeled as A in this diagram. So the timer module or the input capture module doesn't care about this point or this point. It's only going to be keyed up to react if it sees a rising edge. Now the first rising edge occurs just before the reading of 9. So it can only read an integer value. It can't read, for instance, here 8.4, it can only read the next value that's coming up, which is 9. So it's going to write T1 equals 9 into the IC buffer, and the flag is going to be set. Also, at 9, because the way I've set this up as the timer is counting in tens, the timer flag is set at D, right? Now the second rising edge occurs over here at just before 8. So it's going to record the second reading, T2 equals 8, and it's going to write 8 into the buffer, overwriting the previous value, which was 9. Again, the IC flag is set. And the process is going to go over and over and over again. So the time we're going to record for edge to edge is this 9 to that 8. Well, 8 minus 9 is -1, but you have to account for the fact that the timer has rolled over. So here's the edge to edge time, right? So it's T2 minus T1, but if the flag is rolled over, so that this is 1, then it's actually T2 plus the timer period minus T1. So in this measurement, the timer edge to edge was 9 clock intervals, right? Which is good for us, not a problem, easy to do. We'll probably be getting much bigger numbers than this, so it would be even closer. N is the timer prescaler used, and TPB is the peripheral bus period, whatever we set it to be when we're setting the clock. Let's talk a little about the software to make this happen. So the functions that are in plib are open capture, input capture pin X, whatever that is, capture ready. That tells you whether or not there's a data point in the buffer. Input capture clear interrupt flag clears the flag. Recapture is like read timer, you get to read the buffer value. And then close capture, close the module. And again, I'll remind you that timing can be done either using a 16-bit timer, either timer 2 or timer 3, or using the 32-bit timer for much longer time intervals, which is timer 2-3. You should configure and set up the timer before calling the input capture module. Now, the only function that you really have to configure is the open capture one, the one that configures the input capture module. We of course want to set it on, whether you're going to use a 32-bit or a 16-bit. Okay? If it's 16-bit, this is the different timers you're using. If you're 32-bit, IC timer 2 source really means you're using timer 2-3. The next one, when we mode that we want to look at is this one right here, the mode select. You can tell the module to find every 16th rising edge. So it has an checks every 16 and then enters a value, or every 4th rising edge, every single rising edge, every single falling edge, every edge. And now there's another one, this one, specified leading edge, then every edge. And these ones are essentially the same. They time every rising or falling edge. This one's actually a little more useful because there's an ambiguity in timing. Okay. So here's 2 signals, and if you capture every edge, you will get the 3 times for the first edge, second edge, and third edge. But these 2 signals look very simple. very similar. So if you used I see every edge as a possibility, you couldn't distinguish between these two setups. But if you use the leading edge is, or the first edge is a rise, then we know we're using this one, or we're recording the data for this type of curve, as opposed to this one, where we're doing a fall. We'll do a few examples in code so that you can show the difference, or you can see the difference, sorry, so that I can show you the difference. So let me call up an example program right here. Okay, this is called testcaptures.c. Again, it's in examples. And what I've done is, so that I have a signal to test, I've actually got a pin set up as a PWM signal. It's going to be 2000 TPB wide and on for 500. That's going to be on reprogrammable pin 7. And that's my PWM signal again. This signal is for the open capture, and one thing I like to point out, usually, and this always seems a little strange, close capture 1 before open capture 1. This just makes sure that all the settings are reset to default before you open a module. It's something that the data sheets recommend that you do. And the open timer here has been set up for a tiny time interval of 4,000 units. And I did that on purpose because I want to show you what happens if the timer units are too small. So here we're timing every edge. Okay. So every edge, and so that means all the rises and falls. We're not specifying whether it starts with a rise or a fall, so there will be certain ambiguity. So I'm going to compile that. I've already got it compiled, and I'm going to collect some data. Okay, you can see I've collected some data. And if you look at the time from the first signal to the second signal, you can see it's 500. Going back to the program here, right? That's the on time for the signal, 500. And the period of this signal was 2000. So when I go back to the signal, right, from here to here, this is one full period, 2000. Now 500 more should be 4457, but we only count up to 4000 on timer 3 here, up to 4000, or on timer 2, sorry, only to 4000. So that clock rolled over, and I know that as well because I have the flag coming out at 1. So I'd know I'd have to add 4,000 to this before I try to do any differences with these guys. I'm going to make one little change here. I'm going to change this so that it records every rising edge. So every rising edge. Let's see. But here. So this is only going to do every rising edge. And this was a crazy small number, so I'm going to make that much bigger, so I shouldn't have any timer flags come up. And I'm going to load this and pause. Well, okay, so I've compiled and loaded the program, and now I'll call putty up and run the program so we can see the results. Okay, so it was on a 2000 TPB signal, and rising edge to rising edge you can see 2000, then another 2000, and another 2000. So the period is 2000 as expected from the signal I've generated. I've got many different possibilities for how I time these guys. Okay, so that was every rising edge, could be every falling edge, every 14th or 16th rising edge, or me with specifying which edges I want. That's it, I think, and bye for now.